So without any further ado, I'll turn the podium over to our keynote speaker, Russell Barton.
So before I go any further, let me just also mention I am an employee of NSF right now. They pay my salary through Penn State. And as an employee of NSF, the lawyers have told me that I need to let you know that what you're about to hear is my opinion, and it may or may not correspond to NSF's point of view. So when we move from the 1960s to the 1970s, it's still hard to get money. It's still hard to find places. You do have more opportunities in computer science. Now, I'd say in the 70s, we moved from looking at math and management into computer facilitation of what industrial engineers do. And these two grants give you two different aspects of the way that we moved in the 1970s. First, Alan Pritzker had a grant looking at a strange topic, right? Self-contained building concepts and analysis. So how do I understand if I want to capture all the social working functions, every possible social function in a single building to capture community life, everything you can think of, from the arts to employment, to living, to recreation, everything captured. How do you design a building like that? Well, one of the tools you might think about using is simulation, and this funding was part of the route that led to many of innovations in simulation research and application, and Alan Pritzker was at the root of a lot of that. John Jarvis had a grant of a different sort. So this is the first place where we see decision support tools that are computer-enabled coming into play. And in this case, he was working on, he had received funding for something I think was called ECLP. So to help, in an undergraduate setting, people to capture the characteristics of linear programming problem with a nice user interface, and then to be able to get answers. I think it was maybe 50 constraints and 100 variables could be captured with that model. Then we actually move into an era where things were happening much more quickly. There was a program in 1979 established called Systems Theory and Operations Research. It was within the electrical engineering program, but it was finally a formal home where industrial engineering faculty could apply for grants, and we see an explosion. Well, maybe not quite an explosion yet, but a lot more grants. Some of the names you see on here you will recognize. Again, as with the previous names, people who wound up being leaders in the field of industrial engineering. And I don't want to go through all of these. I will mention Ryan Cooler's grant for information productivity models. Before that, in the 60s, he was working with Morse on applying operations research to libraries and had a book on that, among other things.
So industrial gases, in a nutshell, are products that are utilized and in many ways have some characteristics of the fundamentals of industrial engineering. A little digression, most people have asked, so chemicals, process industries, chemical group, how come an industrial engineer is leading a chemical company? I sit on the American Chemistry Council. And I remind them that, so if you look at what our products do, we make and help our customers be more productive, to drive and improve energy efficiency in their manufacturing processes, to improve their product quality. So my example of using liquid nitrogen to flash freeze fresh vegetables, or using oxygen in a steel mill to improve the throughput or the product quality, or to reduce the natural gas or the hydrocarbon consumption in that facility, are all great examples of how, in my mind, we're applying fundamentals of industrial engineering techniques and practices. The other aspect of what our products do is that they make or help our customers make their manufacturing process more sustainable. Most of our products have a sustainable benefit, so that paint can that's shown on the lower left there. If you ever bought paint 20 years ago, it was called oil-based paint, and it had a certain smell to it. So it was oil-based paint. It was made from petroleum or solvent-based products. Today, most paints are water-based paints, waterborne chemistry. We were one of the first in driving away from solvent-based chemistries to waterborne chemistries in our coatings business that goes through our performance materials business. So one example of environmental friendliness. Another example, you all heard about, clean transportation fuels, ultra-low sulfur diesel and gasoline to reduce NOx and SOx and particulates and clean up the environment. We're the world's largest producer of the hydrogen that goes into the refining of those products, that eliminates that sulfur and reduces the particulates. Are just a couple of examples of how our products not only provide that productivity or efficiency benefit, or a quality benefit, but generally speaking, we like to provide those economic drivers for our customer and also do it in an environmentally friendly manner. When we look at our product slate, we really believe that something like 70% of the products and offerings we have really fit the definition of a truly sustainable product.
It's great to see the number of students that are here. No pressure. The future of the world's in your hands. I'm reminded of Charles Dickens in his Tale of Two Cities. You can look at this as the best of times or the worst of times. When I meet the students that are involved in engineering school today, I'm convinced that our best times are ahead of us because you're brighter, you have better tools, you have a better understanding of what's happening globally than a lot of the folks that went through school with me do. So I'm sure that we're getting ready to enter the best of times and not the worst of times. My presidential theme at ASHRAE, Maintained and Sustained, came about because some of the best designed and best constructed buildings in America faded from green to gray because the people that operate those buildings don't understand how to take advantage of the energy conserving features that are built into those buildings. So I tried to emphasize over my year of making talks around the world that we have to focus on keeping our green buildings green. When I was president of ASHRAE, I visited 16 countries, and I was surprised to find out that the challenges faced around the world were pretty common. Cost and availability of energy, cost and availability of food, and protecting our environment. We'll talk a lot about energy today. The one that was a surprise to me was food. Early in my term, I shared a platform in the Philippines with the Assistant Commissioner of Agriculture for the Philippines. And he mentioned the food crisis that exists in their country. Now, I don't think that we've ever had an availability crisis in the United States, but if you did the shopping for your family, you might think that we have a cost crisis in certain types of food. Of course, food prices are influenced to a great extent by energy prices because we use a lot of energy growing our food. We also divert some food stocks into energy production. The real tragedy is that in a world where malnutrition is one of the leading causes of death, a third of the food that's harvested is spoiled before it ever is consumed. I've asked the ASHRAE Refrigeration Committee, and they're well underway, on a project to develop a refrigeration system that's so simple that anybody with a screwdriver and a pair of pliers anywhere in the world that can keep a Jeep running can keep that refrigeration system running, because the developing parts of the world are where most of the food spoilage occurs.